Good evening, friends, and welcome to this webinar, which is, on a topic which is little unfamiliar for the structural engineers generally. That is Net Zero Carbon 2050 Act right now. My name is Alok Bhaumik, and I am the president of Indian Association of Structural Engineers and host of this webinar. Today's speaker is Mr. Vijay Kulkarni, a stalwart in the field of concrete technology, very well known in the field, and a champion for the cause of sustainability and climate change. The webinar will be moderated by Mr. Manoj Mittal, who is the past president of IS Shakti and an eminent personality in the profession. Friends, this topic of the day is extremely topical in today's scenario. Uh, we all listen to or read about climate change in newspapers. Many of the professions and the politicians talk about climate change. Climate change is a frightening reality that will test the future resilience of all our infrastructure. Uh, and as a structural engineer, we have a huge role to play uh, to to sort of bring down the carbon footprint. We have only one globe and one set of resources. But if you really look at the population figures, currently the world's population is about 7.8 billion, and by 2050 it will be about 9.5 billion. And if we live the way we are living, the requirement is that of three globes to fulfill as far as the resources are concerned. And no, naturally, it means that we have to mend our ways if we want to control this global warming. And who can solve this? I mean, how do we solve this problem? We structural engineers, need to get our head up and realize this stark reality, and we need to get our act together as structural engineers and seek influence. So far, our codes, our standards, our practice hardly takes note of this stark reality of climate change. Let us get back to responsible engineering in the real sense of the word for the benefit of a sustainable and resilient world for humanity. With this opening remark, I would like to hand over this platform to my colleague, Mr. Manoj Mittal, who will moderate this session. But before I do that, I have the honor and privilege to introduce Mr. Manoj Mittal, who is the past president of IS Shakti, graduated in civil engineering from BITS Pilani in 1985. He also earned his MSc and MS degree from the same institute. He is practicing as consulting civil and structural engineer and has an experience of more than 33 years. He's a member of several professional bodies. He's a member of Institution of Engineers India, fellow IAS Shakti, Indian Concrete Institute, Consulting Engineers Association of India, CDC, Association of Consulting Civil Engineers, ACI India, IBC, and IOV. He is also member of several BIS committees, for example, CD 29, CD 54, CD 46, Part 4, Part 11, and Part 19. Presently, he is also affiliated with SPA New Delhi as a visiting faculty. He also served on the board of Power Grid as independent director. With this, I would like to hand over the floor to Manoj for taking this forward. Manoj, please.
Thank you, Alok, for introducing me. As you said very rightly, this is a very important topic. And unfortunately, many structural engineers feel that this is not their domain. But I always say that traditionally we design our buildings and structure for functionality, for safety, or economy, I always say the sustainability should be the another dimension of our design. All our structural design, construction practices, and all those things must have this sustainability as an important aspect. This should be the important aspect in our designs. Now, interestingly, National Building Code also has a new chapter called which they have included in NBC 2016, which is regarding a sustainability approach to design. This has been covered in detail. How to design the buildings considering sustainability aspects. And also in CD 39, CD 29 and BIS, we have a standard on sustainability management. Now, just like we say quality management, time management, cost management, procurement management, now we have a standard on sustainability management also. So this sustainability is being considered very seriously, and BIS has also taken a lot of efforts, and I'm involved with many of these committees, and I was a co-convener of the sustainability code. So I think this is a very important aspect, and I'm very happy that Mr. Kulkarni has agreed to make this presentation to all the structural engineers. And just I wanted to convey that recently Mr. Kulkarni contributed a paper on this theme in our technical journal, which is the SED, Structural Engineering Digest. And I'm very happy that now everybody will be able to listen to Mr. Kulkarni on this topic. Further, it is also very interesting to see that in India, we always believe in worshipping the nature. We always worship the river, Ganga, we worship Prithvi, we worship. We do all those things, but still, and we always believe in conservation and saving and spending less and consuming less. But still, I think we should be at the forefront of on this effort of sustainability and countering the climate change and all those things. We should be the world leader actually. So let's see how far we have come and how we can do this. Mr. Kulkarni, I'm sure will be able to throw light on it. So I hope it will be very good and interesting mm, talk. Now let me introduce Mr. Kulkarni. Mr. Kulkarni has more than 40 years of experience in different spheres and in the design of bridges and buildings. He has a very diverse experience I'm seeing into the design of buildings and bridges, R&D in concrete, HSP, HPC, NDT, health monitoring of structures, and ready mix concrete, green concrete, and technical. He is a very he's contributing to write by way of writing and presenting all these lectures and all those things. So he has a very wide spectrum of experience. And further, he was a principal consultant to RCMA. I think RCMA is Ready Mix Concrete Manufacturers Association. So he was a principal consultant to that and contributed to the development of implementation of quality standards for RMC. This is another very important aspect because these days everybody is using RMC and to quality standards and maintain the quality and all those things are very important. So I'm very happy to have Mr. Kulkarni here. And he is also past president of Indian Concrete Institute, ICI, and he is a past editor of the Indian Concrete Journal also. That is a very good technical journal which we receive through email and we go through it as a very quality journal. He was the editor of that also. So welcome, Mr. Kulkarni, and we are looking forward very to this very interesting talk by you. And for the audience, I will suggest that you should keep your mic mute, and if you have any questions, then you should post your questions in question answer, not in chats. Okay, and at the end of the talk, we will take these questions, and Mr. Kulkarni will be happy to answer these questions. Now over to Mr. Kulkarni.
Yeah, thanks a lot, both Alok and Manoj, for a brief introduction and saying few good words about me also. And Alok has started, and Manoj also has supported him on this topic. So my objective of today's webinar is basically to, create awareness about this new concept of net zero carbon, what's happening outside. And it is very interesting that structural engineers are taking a lead in this. And in India, as Manoj has said, that we are lagging behind. And I feel that ultimately the objective is that the structural engineers should take the lead in this matter, and help in mitigating the adverse effect of climate change. Uh, this is the brief background of my presentation. I'll talk on climate change in impact, then operational and embedded carbon. I will also touch upon the Indian scenario, and then how we can reduce both the operational and embedded carbon, and material efficient design, and also the conclusions and way forward. I must give acknowledgement to a large, I think very little contribution is from my side as a whole, because I have referred to large number of documents which are published in the world, and also I have, as Manoj just said, I have contributed 5 papers on this topic as of today. So let us start. I think the topic sustainability, as we know, we have been talking and talking about it, but the real, I would say, the turning point came in 2014, when the Intergovernmental Panel on Climate Change has published a report, and which suggested that the greenhouse gas emission, which consists of basically the CO2, then methane and nitrous oxide. So it said that the CO2 emission has been highest in 8 lakh years, and also the global warming has been also unprecedentedly high in 1400 years. So this is, I think, the turning point where people started thinking as to that this is becoming a very serious problem. And then came another report, I think in 2018, from the Intergovernmental Panel on Climate Change, which showed that the average temperature of the globe, which was just around 0.25 in degrees centigrade, it started rising, and as you can see here, it has reached more than 1 degree. And now, if we go on doing what we have been doing now, as business as usual, then there is a likelihood that this temperature can go up to 2 degrees centigrade, and which will, in fact, the scientists are saying that 1.5 degree is considered as a tipping point for the climate, and some immediate action has to be taken. We have a certain devastating effect, whether it is of floods or cyclones or maybe drought or even wildfire. I think these are considered to be the adverse effect. And if you see the report of the UN Office of Disaster Risk Reduction, you will see that the number of disasters has been increasing in the last 20 years. Floods 44%, storms 28%, earthquake 8%, but mainly these storms and floods are related to the climate change. I think there has been a steep increase in the cost of the disaster, and I think it has gone up to $3 trillion as a whole. So it's a huge cost the mankind is paying for the disasters that are happening. And unfortunately, India ranking in the third number in where India witnessed a disaster in different parts of the world. I think so. As far as we are concerned, this is a very serious issue, but yet we have to grasp. I think there has been a good amount of work which is done by the United Nations Framework Convention on Climate Change, and they have been holding uh, every year on conferences. But the main, I think, watershed in this was the Paris Agreement, which was in COP21 in 2015, where 169 countries finally ratified that they will do something to bring down the temperature below 2 degrees centigrade, and also effort should be made to even further reduction up to 1.5 degrees centigrade. Unfortunately, in 2017 we saw the biggest emitter, that is the USA, withdrawing from the Paris Agreement. But fortunately for the climate, I think USA under the President Biden has again agrees to rejoin the UNFCCC efforts of mitigation of climate change. So this is on the positive side. But I think in the meantime, the moments has been increasing, and 11,000 scientists, I think to be accurate, 11,253 scientists in 153 countries have said that the climate crisis has arrived and is accelerating faster than most of the scientists expected. It is more severe than anticipated and threatening the global and humanity. So this is what the unanimous opinion of the scientists, and which we should really consider. And simultaneously, those people who have been affected, there has been a moment all over the world happening, and for forcing government and the community to take climate friendly action. I think it is epitomized by a young Greta Thunberg, which everybody knows. And then we have a number of countries committing. The first, one of the first was the European nations, European Union, which they have, become. They have decided to become climate neutral by 2050. And as this, the statistics stands today, 120 governments in the world has made commitment to net zero by the middle of century, and this is come from the international energy association's recent press release. Yes, there has been some very interesting initiatives from the private sector, and number of companies have come forward, and they are themselves are setting targets, science-based target, and many companies have also committed to, 1.5 degree temperature reduction, and also I think, unfortunately, we have seen the emissions came down drastically during the lockdown, but as the recent data shows that after the lockdown has been lifted, there has been again an increase in the emission, almost 2%. And then the net zero commitment, that is what people are saying, that just by making commitment is not enough. We need some positive action. There has been a institute, Indian Institute of Tropical Meteorology, under the government of India. They have made this very, frightening kind of a scenario. But fortunately, this happens to be in 2100, that is about 80 years from now. So they are not talking of 2050. But anyway, this is a frightening scenario as far as India is concerned. Now, we also have faced, there is another report which has come recently, and that is regarding the Asia Pacific region, which shows that this is the region which is, witnessing a devastating kind of disasters, and eight to 10 deadly disasters has happened in our area. And India, of course, happens to be more vulnerable in the Asia Pacific region because of obvious things that we have a high population density, we have a fragile ecosystem, economy is not that strong, and the resilience, we have very low resilience to climate change. So we have to be really very serious about these things. Now, there are examples, of course, a number of videos are here, but again, I'm just reminding you as to what's happening. This is the floods in Kerala. I think in the pictures are there. I think this is again floods in Uttarakhand, which I think these pictures are well known. But I'm just repeating it. Then droughts in Maharashtra, and again, the cyclone in your Varda in Tamil Nadu, where you can see that what devastations are being created by the effect of climate change. And the worst part is that both the intensity as well as the frequency of disasters is now witnessing. And there are, of course, the silent victims of climate change. Estimated 2 lakh farmers have killed themselves because the crops have failed. Now, why? We as a structural engineers should think that the climate change is, we can do something to mitigate the effect, because it is said that it has been proved that buildings and the construction sector presently account for large amount of energy related CO2 emission. And it is said that one of the most cost effective ways to to avoid the adverse effect of climate change can be done by decarbonizing both the building and the construction sector. So we play a very important role. A structural engineer and the engineering fraternity as such, they play a very important role, and this is to be understood. For example, this is the latest statistics from the International Energy Agency, which shows that the global share of building and construction in the energy is almost 35%, whereas the emissions from building and construction is around 38%. This is the global scenario. So in our country also, the picture may not be different. I will just try to briefly tell about some of the climate friendly initiatives which has been taken recently. Of course, the leading thing is the World Green Building Council, which has declared that by 2030, all new building will be net zero in operational carbon, and 40% of the reduction in embedded carbon. I will come to that operational and embedded carbon later. And by 2050, they want to be entirely net zero. Now, there are other professional bodies, for example, Architect 2030, they have also committed to reduction, greater reduction. Then there is Structural Engineers Institute AC 2050 initiative, same thing. I think more or less they are agreeing to be net zero by 2050 or so. There is interesting work done by LETI, that is the London Energy Transformation Initiative, where I think people like you and me, 1,000 built environmental professionals consisting of all leading structural consultant, architect, builders, etc., came together forward, and they published 2 guides, and they have embarked upon making London as the zero carbon. There is Carbon Leadership Forum, which has also, these are all non-profit making body, professional body consisting mainly of structural engineers, architects, and all civil engineers. One of the major work is also done by the Institution of Structural Engineers UK, which has declared that it is the structural engineers have a responsibility to help mitigate effects of carbon by changing the way the building and infrastructures are designed, commissioned, and constructed. So this is their thing. As far as many, material related organizations are concerned, they have also been aligning themselves to these goals. I come from the cement and concrete sector, so that is why I have this data from SEM Bureau, that is the European Cement Association, which says that all 5 Cs, that is, they want to reduce the carbon from clinker, cement, concrete, construction, and recarbonation. So 5C, and they have given the targets also by 2050. Entire Europe, they want to make net zero. There has been a large amount of research work which has been going on at the moment, and very, very active research. One area is improving energy efficiency related to the production of cement and other building material. And two other interesting things are, they are also thinking of capturing the CO2, that is carbon capture, use, and storage. In fact, the Global Cement and Concrete Association, which is taking a leading role in this, I think one project is at the moment going on in Europe, where Heidelberg, Vicat, and 2 other cement manufacturers are there, and they have been successful. And ultimately, they want to have a pipeline all across Europe where they can capture the carbon, transport it, and use it. So this is a interesting area. And second thing is the development of low carbon cements. Great work again has been done on this topic. I think you are all aware that EN 2197 on cement, they have a category called CEM3 cement, CEM3, and CEM3 part A, B, C. So if you go to C, the CEM3C cement contains only 5 to 15% clinker, and the rest is all ground granulated blast furnace slag. Now, even this 5% is now being thought about and reduced. And I must mention that even India is also leading in this, and I'm happy to know that recently Tata Steel has got a patent on almost zero carbon cement and concrete. So all works has been going on in this direction, and this is from the Global Cement and Concrete Association. Similar work I just mentioned about cement and concrete, but other materials, because in building we use large number of material. In construction also we use hundreds of materials, and lot of materials are energy intensive. So every material we have to consider as far as this is one area where I think Lafarge Holcim has come out with EcoPact cement. Many other cement companies have also come. I think Cemex has come about, and many other companies will follow. Now, before we think about operational and embedded carbon, let us try to first understand certain small definition. Nothing great about that. What is to be understood is that carbon dioxide equivalent is briefly referred as carbon. So whenever I'm saying carbon, I mean carbon dioxide equivalent. And carbon dioxide equivalent encompasses all greenhouse gases, that is carbon dioxide, methane, and nitrous oxide. And 1 kg of carbon equal to has a global warming potential of 1 kg CO2e, and then the whole life carbon is equal to operational carbon plus embedded carbon. Now, how do we reduce the operational carbon? So this operational carbon comes because of the energy used in buildings service life, and it can come from all energy centric operations like heating, cooling, ventilation and lighting system, or maybe the all the equipment that we use, that is fridges, washing machine, TV, computers, etc. And World GBC goal, and many people are adhering, even Architect 2030, that the net zero operational carbon has to be achieved by 2030, and for the new building and for all existing building, net zero operational carbon by 2050. This is the commitment. Now, how do we do that? Before that, I think we must understand the operational carbon. I think we, as Manoj and Alok has been saying, our standards talk about passive design, where we talk about orientation and envelope of a building, and they also talk about energy efficiency of the equipment that we use. But then we also have to think about renewable energy, on-site renewable energy as well as off-site renewable energy. So if you think about a small residential building, a small scale building, then the total operational energy can be met with solar mounted PV panels or by other renewable energy. For example, we can have the photovoltaic cells fitted on the top of our building. Now, in case of high-rise buildings, it will not be possible because the roof to floor area is smaller, and that is why they have to invest in additionally in the off-site renewable energy like solar farms or windmills, or even the world GBC, or they are giving you a freedom that okay, it's not possible for every building to become use the renewable energy, but what they say is even at a national level, all your energy consumption of all new buildings should be at least equal to the total renewable energy potential of the country. So as a country as a whole, we need to create so much of renewable energy that it takes care of all the operational needs of all building in our country. So very simple. Now talk about the second aspect, embedded carbon. And when we talk about embedded carbon, there is a standard which has come, that is the EN standard 1595, and it has categorized the entire life cycle into 5 areas. One is the product and the construction stage. This by yellow, and then there is a the construction process also, transport and then the construction, then the use involving B1 to B5 and B7 also, where all aspects of use, maintenance, repair, etc. are taken care of. Then comes about the deconstruction stage, and this is where a change is happening, that today we need to think about the deconstruction. We never thought about it, or we have not given due importance to deconstruction process and what will happen after deconstruction, that is beyond the life cycle. So the entire spectrum we have to consider and then find out how much is the embedded carbon from that. How do we calculate that? So there is a life cycle assessment process of all phases A, B, C, D, and we have to consider all phases right in the design stage. And how we do it? We can have different alternatives of design and choose the one which is having the lowest carbon. So as Manoj has been saying that in sustainability, when we consider, we have to account for carbon. As of now, Indian codes is not accounting for carbon. And how to estimate? the embedded carbon? Very simple, very simple. Embodied carbon equal to material quantity multiplied by embodied carbon factor. So the crucial issue here is, what is the embodied carbon factor? And Institute of Structural Engineers UK has come out with a guideline, and I think they have given you the embedded carbon factor for almost everything that is used in the building. I just give one example here. So from A1 to A3, whatever has been the factors they have calculated, and they have made it easily available to all the structural engineers, architects, etc. Now the question is, what about us? So before we go to that, let us see the Indian scenario very quickly. Uh, uh, India happens to be the third largest CO2 emitting country, and this is a well-known fact, I think, next to China and USA. And considering this, our Prime Minister has committed in the Paris Agreement that we will reduce the greenhouse gas emissions by 30 to 35% relative to 2005 by 2030, and to achieve about 40% cumulative electric power from the non-fossil fuel. Out of that, I think the 100 gigawatt coming from solar power, 60 gigawatt from wind power, and 15 gigawatt coming from. So total 175 has been committed by 2022, and work has been going on. And I must say that there has been a great increase in the capacity installation of renewable energy in the country. I will show you this. Of course, they are also talking of planting more trees, which can act as a carbon sink. Now, interestingly, there is a India CEO forum on November 5th. I think the meeting was held in Delhi, where the Prakash Javadekar chaired the meeting, and there were 24 participants in the meeting, all top companies, Reliance, Tata, and even from cement, you see ACC, Ambuja, and JSW, and many others. And many others will again join. And what we see that they are agreed to achieve, reduce the greenhouse gas emission. But unfortunately, there is no commitment as such on net zero. Privately, some companies might be, but as a CEO forum has not committed to net zero. So again, wishful thinking. I think we should also commit. This is my personal wishful thinking. As a simple climate warrior, I feel that we should also try, when others are trying it. Why not we try to become net zero in the new building that we design by 2030, and then slowly apply the whole thing to both operational carbon and embedded carbon, and become totally net zero by 2050. Question is whether there is a balance between the renewable energy and the operational energy. And we see that India is fortunate as far as the renewable energy is concerned, and you can see here the potential. We have a huge potential, huge. Actually, total potential is estimated to be 1,000 to 1,300 gigawatt. And at the moment, I think this is what is committed by our Prime Minister. And there has been a great improvement, as you can see here. This is the portion, 23% of the capacity as of today. That is why, this is the data as on 2020. So 23% of the total energy, capacity is coming from renewable energy. But fossil fuel still remains the main, energy provider in India. Now, let us see a renewable capacity as of December 29 and the target, and you will find that although we have made a lot of efforts and a lot of efforts are continuing, yet I think we are falling short of 50% target as of now. And I hope that by 2022, we should be able to achieve this. Now, in buildings, this is what we know that globally they consume almost one third the energy and are responsible for 40% of the direct CO2 emission. And but in India there is no record of the total energy requirement in the building. I visited our ECVC, Eco-Niwas Samhita 2018, where they have said that that the building sector in India consumes over 30%, and out of which 75% is residential. But we have another projection from NITI Aayog which shows that the electricity consumption in residential building is bound to go up, a jump of almost 50%. Interesting graph I could find out from a recent publication from the 19th Electrical Power Survey of the Central Electricity Authority of the Government of India. And they have estimated that in 2021, we 15 lakh MUS is the electrical energy requirement, and it is going to increase by 2037 almost by double. This is their projection. Of course, this is optimistic and pessimistic, but more or less, I think we may reach this figure, and there are reasons for this, why we will reach a big jump in the energy requirement. And this can be seen here by the report from the International Energy Association 2021. They have a special publication on India Energy Outlook, which shows that India will be adding an equivalent of a city of the size of Los Angeles to its urban population each year. So our urban population is bound to increase, and by 2040, I think we will be adding almost, I think, 270 million people. 27 crore people will be added to the urban population. This is the estimate of this body. And around 30 million meters square of floor area will be required, 70% in urban area. And there will be naturally a surge in the demand of energy intensive material like cement, steel, bricks, etc. And what will also increase is, because of the appliances are available, the need for cooling will increase because of the climate change. We will be, witnessing great increase in the temperature, and the cooling requirement will increase. So that is why a jump is happening from 2019 to 2040 in the energy requirement of building. So what we need in India is a great leap forward. I would say a great leap forward as far as the operational energy is concerned, because India has a large potential, but presently is not tapped. And what we can do as a civil engineer or a structural engineer is that the rooftop solar, I think only 2.33 gigawatt is being used today, whereas the target is 40 gigawatt. Reasons for poor use: Everybody knows this, that there is a lack of awareness and initiative by the society. We live in cooperative housing society or individual society. And there is a tendency amongst every Indian that whenever new thing is there, he is asking for subsidies. I don't know why. We should not ask for subsidy. In fact, I have found that it is not a very costly thing, but people are just reluctant to use it. They want somebody else to use, do their job. But even in in Mumbai, I have seen that there are many people who come forward and say that we will make the initial investment for rooftop solar. You don't have to worry, and we will bear the charges and take out the charges, and then rest of the years, I think you will benefit because your energy bills will come down. But yet, I think there is a great resistance from the state electricity board to install the net metering facility. Net metering is allowed by the government now, and you can get a reduction uh, in the energy bill if you are using renewable energy. So I think in this area we need to target as a designer, that whatever new thing comes, it should have necessarily a rooftop solar or any other renewable form of energy. Now, sweeping reduction in carbon is essential. I think I made a small attempt and in 2017-18 when we did this Redmix concrete certification of a green product, and then we certified some 17 plants across the country. And then after the certification has happened, we have collected the data after 1 year, and some improvement has been found. This was the certification stakeholders, and what article is published on this in the Concrete International of American Concrete Institute on this topic. And what we could see that the average supplementary cementitious material replacement has been reduced by 26% because of the awareness created in different plants. And the specific energy use has been reduced, the specific water consumption has been reduced, and the CO2 emission as such has been reduced by almost 7% in the concrete products. But this is a very, very small effort. We need to do a lot. We need to do a lot for all other materials. So we come back to the life cycle, and what has been said here in the Institute of Structural Engineers UK, that majority of the energy is during this production stage. So almost 50% of the energy is required in the raw material production, and 20 to 23% in the operational use. Other energies are not that very, very great. So we need to concentrate and see that the product that we use are so we have seen that the embedded carbon can be calculated by the material quantity and the embedded carbon factor. But the crucial question is, how do we get the embedded carbon factor? So this is, I think, in United States and many other European countries, there is a practice of using environmental product declaration. All the industry, they have this environmental product declaration, and you can get the data. This is one example how the United States has carried out the environmental product declaration of RMC in their country. And once you know the global warming potential of the average thing, then you can plan your data accordingly. In our country, I think in Europe, I have seen that there are many companies and many associations which are, today saying that they can give you the EPD values or environmental carbon factors from your product. But in India, no effort is visible. Incidentally, I have some interesting data on the cement because I come from this cement and concrete sector. So here, what you can see here, this is the data again from Europe, which says that this is the ordinary Portland cement, which has a global warming potential of zero point 0.6 to 0.8 kg per CO2e per kg. And as you go for blended cement, the thing come down. This is the SEM3 cement. So as you use more and more supplementary materials and reduce the use of ordinary Portland cement, you can get lower carbon. Another interesting thing is for concrete as a whole, one interesting thing is that for the same strength of concrete, say 20, 30 MPa, 40, 50, 60 MPa, different values of global warming potentials are can be seen, and this is because they are using a different percentage of OPC. But what is interesting is that even for high strength concrete, that is M60, 70, 80, the values are much lower. So you can see that higher the strength, which is now required for tall buildings and many other applications, bridges, etc., they have a lower embedded carbon factor than you would have thought otherwise. So I would say that the responsibility of providing the embedded carbon factor lies with the material manufacturer, and they should adopt. And our structural engineer body should request all the material manufacturers to estimate their embodied carbon factor and give it to us so that we can and get it verified by a third party. Of course, this is important because we can't believe everybody. So, and then once we get this, then we can do the design. A real material efficient design can be done, and this is essential because nearly 50% of the embedded carbon is between the category A1 to A3, and reinforced concrete structural adequacy cost, and we need to have a optimized mix design wherever we are using concrete. And so one interesting thing that I have found is from of course there are many people who have come out with spreadsheet and softwares, but this is well known from the Concrete Center from United Kingdom. They have called concept V4 software, and they have typical data of a building, multi-storied building, where they have considered 13 alternative possible alternative, and they have also beams and columns of various grades, and rebar grade is also given, and then they have estimated the total carbon for various alternative and found out that this particular alternative two-way slab gives them the lowest carbon. Here you can see from this spreadsheet design. So interestingly, such things are possible, and a structural engineer is capable of doing all these calculations very easily. One area which also need great attention, and here again we have to struggle very hard, that there is very little work done on green public procurement. as far as India is concerned. And the data, I think I got this data from a report from Global Efficiency Intelligence USA, that they say that public procurement account for 30% of our GDP. So most of the work are under the government of India and various other state governments where public procurement is happening. And there is no green public procurement. So we are not insisting on green public procurement, as a result of which, the embedded carbon and the operational carbon is very high. I have found in this same report that even China, and I think this report gives data on 15 of the top CO2 emitting countries, and China is, I think, way ahead in green public procurement. But we have to do something. We have to have regulation actually, and we have to have eco-labeling system and certification for various materials. And this, unless the regulation is there, we have to, force the government to bring such regulation. So I'll now finally come to the conclusions of this talk, that climate emergency is a stark reality. India is prone to a devastating effect of climate change, as we have seen. 120 governments have already committed net zero. In India, 24 private companies have, set achievable greenhouse reduction target, but as of now, no commitment on net zero. Building and construction sector account for nearly 40% of the carbon emission, and decarbonizing is one of the most cost-effective way of operational carbon can be used, reduced by using, renewable energy, solar, wind, etc. And a great leap is required for a rooftop solar or rooftop wind, etc. Embedded carbon, I think architect and structural engineers need to design building having lowest embedded carbon, and all materials manufacturers should provide ECF of their value. Material efficient design, a good tool to reduce carbon, and both cost, I think cost also can be reduced. So what our industry need today is a roadmap to achieve sweeping reduction in the operational and embedded carbon. And what I would suggest that we have almost 4 or 5 structural engineers association. I'm requesting all the structural engineers association to come together. Why not we come together for a very just cause, and we create a roadmap, and or at least a kind of a small forum can be created by the structural engineering various groups, and their the office bearers can participate in this, and we should design a roadmap to achieve sweeping reduction in the carbon, and we have to take an initiative. I think somebody has to take an initiative, then everything will follow. So this is the small views of a climate warrior. I think I would like to end here. Thank you very much for giving me the opportunity to speak on this occasion, and I would welcome any questions on this.
Yeah, thank you, Mr. Kulkarni, for an excellent presentation. You covered a lot of things. You gave broad perspective as well as the real implementable things also you covered. So I'm sure everybody must have found it useful. So I'm having few questions here. So I think I will take one by one, and thereafter we can discuss more. So this question is from Rajesh Gangwar. He is asking, as use of natural river sand has been banned by court orders, we are forced to use manufactured sand. Will it increase the carbon footprint in construction? Can you answer this question?
Hello, I think Yes, I think first is I think it's a very good initiative which has been taken to ban the river sand, because we have seen our rivers have become literally, a very pitiable thing today because of the over extraction of sand. So we cannot continue to use, otherwise the river ecology gets affected, and that is why we have to use, because we can't stop construction. So we have to use whatever is available, and the best thing available is the crushed stone sand uh, in different parts of the country. Yes, it requires energy, but then what I have said, that we have to think about the totality of the situation, and we have to think about reducing the energy. And whatever little calculations I have done till recently on this finding out embedded carbon from various buildings, I have found that the impact of local material is very negligible, very negligible. And since sand are aggregate, and because they are naturally available, only some energy is inputted into that, but that is not great. I think the great energy requirement coming from basically cement, steel, and bricks, and tiles, and paints, and many other things. So aggregate as such, I don't think they are contributing very big to the embedded energy.
Yeah, rightly said. It will not have much
Yes,
impact
sir.
on energy consumption, carbon footprint increase. So now, second question is from
Yeah.
Nandulal Dasgupta. Then question is, do we reduce minimum cement quantity in concrete from the prescribed value in IS 456? I think he's trying to say, can we reduce? I think instead of do, is it okay? Can we reduce minimum cement quantity in concrete from the prescribed value in IS 456?
I think we can't reduce minimum cement content. What we can say, we can reduce cement content, but not the cementitious content.
Yes.
So cementitious contents has to be as specified in the IS code. IS code has given us the freedom to use 70% reduction in, by using GGBS, and 35% by fly ash. And we have, I think, examples of using high volume fly ash concrete or high GGBS concrete, where we have gone up to much higher percentages. And as I have said, I think geopolymer based concretes have come up, and one example is, I think, I already mentioned about that.
Right.
So this is the future. Yes, we will. The major emissions creating materials, we have to think about a lot of R&D in this area, and come out with a better, quality material, at the same time having lower energy. And the research is going on in this particular area in a big way.
Right. So now next question is from VN Hegde. Mr. Hegde, can you ask a question live?
Yeah, Mr. Hegde, you are welcome.
I think Mr. Vikas has to, unmute Mr. Hegde.
No, but we can hear him.
Ah, he's there. Okay.
Yeah, Mr. Hegde, please continue.
Can you, yes, I think you can hear me right now, right?
Yes,
Yeah,
yes.
yeah.
Yeah.
On Kulkarni side, I think in the beginning of the presentation, you said this topic is not very interesting to many, but I should tell you, this is a very, very important topic, and it's a topic in vogue, whether people like it or not. This is a topic which forces everybody to be interested in. If you are interested in the posterity of ours, in the welfare of the
Yeah.
of ours. By excellent presentation, very informative as well as a very educative presentation, I should say. I have a couple of questions. I have also written a number of papers on the sustainability. Whenever we are talking about the sustainability, especially in the construction practices, concrete construction practices, as rightly explained. One is the embodied concrete, the carbon factor. Other is the embodied energy factor. I always talk about the embodied energy factor also. The sustainable construction practices is nothing but reduction in the CGH, in greenhouse gases into the environment, and also reducing the embodied energy content, which is of the materials which is going into the construction as a construction material. And you have not talked about the embodied energy factor. Is there a concept of embodied energy factor? That is my first question. And the second question is, as you rightly said, why in India, despite having so many institutions like IITs and IIScs, no research has been done on this embedded energy factor as well as the concrete carbon factor? Is it not the order of the day? Is it not the necessity of the day?
I think, Mr. Hegde, thank you very much for raising this question. I think the embodied, first, I think I answer the second question. Embodied carbon factor is the responsibility of the producer. And there is nothing great research needed for finding out the embodied carbon factor. In fact, the Green Certification Center of CII has been doing this work for a long time. And they have done, but you know, somebody has to come forward and tell them that, okay, you calculate our embodied carbon factor and tell us how much it is. So it's not a very difficult thing. They can calculate. Research is not needed. And research is needed only for reducing the embodied carbon factor in a particular material that we use on a big scale, like cement and steel and bricks and masonry and all those things. And second thing, embodied energy factor and embodied carbon factor. Ultimately, the energy that they considered is the major issue in any production. So embodied carbon is coming mainly because of the energy used in the material. And of course, there are, I think, 11 to 13 factors which I have not mentioned, because otherwise the presentation goes into totally a different direction. So there are various other factors, which affects even the various climatic factors. And it's a well-known technology of finding out the embodied carbon factor. There is nothing but only thing is we should take the responsibility, and unless we demand it, the structural engineers demand it from the manufacturers, they are not going to provide it. I think one example I given is Holcim Lafarge. They have come out with on their own they have come out, and Cimex also has come out, and many other will come out of this, provided we exert sufficient pressure on them and we start doing design. Hegde Saab, our design has to be based not only on the serviceability, safety and durability aspect, but also on calculating the lowest carbon alternative. So this is the crux of the presentation. Yeah. And today it is not available. Today we are not promoting this concept. This has to be promoted by the structural engineers, and I personally feel that this will create a separate business for a structural engineer. Why not? His work will have some value, and work will also increase as far as calculating the carbon factor from alternative design and choosing the best alternative which is giving the lowest carbon, and of course fulfilling all the regulatory requirement of serviceability, safety and all other aspects.
Yeah, thank you very much. Thank you very much, Kulkarni Saab. In fact, just for your information, from Consulting Engineering Association of India, while we are giving the the guidance for the pre-qualification of the consultants as well as the preparation of the DPRs, Department of Project Report, we are trying to insist upon this particular factor what you are talking about.
Yeah.
They will have to say that how much carbon footprint in their earlier projects they have saved, by way of embodied. That is what we are trying to encourage. Let us see to what extent you will be successful. Thank you very much.
Thank you.
Okay, now, thank you. Now we have a question from Mr. Umesh Raj Sirke. Is there a direct relationship between the amount of embodied carbon in cement concrete with its price and cost? If they require less energy to produce, automatically the price cost should be low. If it is not, then difficult to promote it.
I think I will not be able to answer this question because I'm not directly involved from the cement sector. But any new technology, when it comes, it will certainly have some additional cost into it. But as the use of a material increases, the cost comes down. So I have said that energy efficient design also gives you lowest cost. So you have to choose the material that you use in such a way that not only the carbon but also the cost also comes down, because ultimately you are working for a client who is also interested in the cost. So cost is also an important factor.
Okay. So another question from Ganesh Gawali. Is there any possibility to include the calculation of ECF in our IS codes?
I think Manoj, you will be able to tell us this.
Actually, at present, they do not have this. First of all, see, National Building Code is at all not mandatory. First, another thing is it becomes mandatory when building bylaws make it mandatory to use the National Building Code. Another thing, this chapter is basically just says is a design approach. They are saying when you are designing a structure or designing a building, you should keep in mind these things. So it is like a guideline kind of a thing. So, but to make it implementable, one should be able to calculate embodied carbon and all those things very accurately. And then probably when you are applying for sanctioning or something, then somebody should be able to check it or get it certified. So those kind of things are there. So at present, I don't think there is as such there's a provision in it, because otherwise it will be very difficult at this stage to get the plans approved or implemented actually.
I think my suggestion is we should not wait for the codes to come out with the provision.
Right.
We should start working on this.
Right.
That is my suggestion. At least wherever possible, the structural engineers can suggest to the client and make him aware. And already we have 24 CEO who are ready. I think it is a question of going to them and telling them that, okay, this is how we will be able to reduce the embedded carbon or the total carbon in the country.
Yeah, and further, see, we have GREA rating, we have so many certification. So idea of BIS was not to go in that direction, but see, ultimately, if you are doing a good design, you are doing good structure, unknowingly, you are actually doing some kind of you are already achieving some kind of a sustainability. So the approach of the BIS was that you do it consciously. You should know what are the factors, what are the things, what are the materials to be used, what are the technologies to be used, and what kind of design you should consider. So then probably you will achieve the higher level of sustainability in your design and construction. So at present, this is the status. As Mr. Kulkarni said, yes, the voluntary organization, the association, the professional bodies They must come out with all those things, and we should start implementing it. I'm sure in time to come, maybe these things will come into BIS codes also, and they will become implementable and mandatory also. At present, they are not mandatory, but in time to come, they will become mandatory also. So it's the right time for our fraternity to learn about it and to get used to all those things. And I think we should start using all those things.
Okay, thank you. This is exactly the message I want to give.
Yeah. So we have a suggestion, I think, comment from Mr. Anil Sharma, who is from CPWD, ex Special Director General CPWD. For information of audience, CPWD has developed a holistic quality rating system of buildings,
Okay.
which incorporates of efficient design, construction, and operation of buildings. This covers efficiency of architectural and structural design and efficient execution for holistic reduction of carbon footprints due to particular building.
Okay.
It's a good thing. Mr. Sharma, can you come live and suggest from where we can get this document, or is it publicly available? Mr. Sharma?
I think Vikas has to facilitate.
Because
Yeah.
yeah, Mr. Sharma can come, then I think it will be better if we can get this document and it's publicly available.
Yeah, sir, I have promoted to panelist, but he is
Okay, no problem.
muted and video is off.
Okay, no problem. Okay, no problem. But yes, we can explore this. It's a good thing if CPW has something like this. So
So this is like this.
yes.
We had been developing quality rating system earlier, incorporating the efficiency in the structural design, efficiency in the architectural design to ensure that it is a passive design, and
Yeah.
also the efficiency of the MEP design, air conditioning, etc. All these things have been incorporated into a single 1 to 10 scale. 1 to 10 scale.
Okay.
And these can be separated also. Architectural design efficiency, how it ranks on 1 to 10 scale. Structural design efficiency, how it rates on the 1 to 10 scale. MEP design, air conditioning, etc. All those designs, how do they rank on 1 to 10 scale? They can be separated, and there is a combined holistic rating system. And this is what I had initiated when I was there in service as a Special Director General. And my job has been continued even after I retired. And they have ultimately come out with the rating system, even though it is a diluted one, but I had already actually conceptualized. But even though it is diluted, it can be further improved upon with the passage of time. With the I could have incorporated, I could have taken it up as originally conceptualized. But you see, successors, they do not have the basic concept, or maybe that concept they might have found it difficult to implement. So because it needs the computerization,
Okay.
it needs a big database. It cannot be done manually. It is required to be based on the computer. It necessarily requires the computer system to incorporate all those factors related to efficiency of different designs of different disciplines within the building construction. So it is very elaborate. It is conceptualized as very, very elaborate, but from the implementation point of view, maybe the people who are in the helm of affairs, they have diluted it so that it becomes acceptable. But it is already a circular is available on the website, and the rating system is also available on the website. Maybe I might not have used the actual terminology, but it quality rating system, or maybe green rating system, something of that sort they have implemented about 2-3 years back.
So it means it can be used by everyone, by the engineers in general. They can use it. They can download it.
It is, you see, they have given the responsibility to, they have created a section. They have created a specialized unit in CPWD Training Institute to work out the quality rating of that particular building. So I do not know the actual scenario, what is how they have implemented it, but that unit exists in CPWD Training Institute, where architects, electrical and mechanical engineers, and civil engineers. All are involved, and it is a holistic quality rating system.
Okay. So then I think we should explore it and we should find out whether it is available publicly or not. If it is there, then it will be.
Circular is available. I have seen it on the website. Right now, I am not prepared to give you the full details. Otherwise, I could have given you the full details.
Okay, sir. Thank you.
Okay.
Thank you for this information. This is valuable information. Now we have a question from Mr. Prakash. He's asking how much maximum fly ash can we use when PPC is used in case of concrete compared to OPC?
I think the code is providing a 35% limit, and beyond that, one can of course use it. They can go up to higher percentage, provided they are not considering into the mixed design aspect. But then recently we have seen the concept of high volume fly ash being propagated, and a number of structures have come out even in our country. I have myself used high volume fly ash in shear wall to reduce the temperature effect. Yes, so 35% is the limit, and I think most of the cement manufacturers have almost reached the 35% limit today, maybe 30 to 35%.
Right. We have a question from Mr. Sitaram Agarwal. Can we not down advices to structural engineers? My understanding is we should promote Green Pro certified cement.
Yes, ultimately the situation should come to that level. That is why I was talking about the public procurement, green public procurement, that the manufacturers need to give and certify that the third party certification has to be available to know the exact embedded carbon into a material.
Yes. Mr. Mani Ghosh is asking which carbon is effective, fly ash or GGBS?
I think GGBS certainly, because we are allowed to go up to a higher limit of 70%. So it is more effective. But of course, finally it will depend on the cost of because we also need to design consider the cost aspect in the design of any concrete structure.
Yes. So many people are asking that whether we will be getting the PPT, and some people are asking whether this will be available on YouTube link. Also, yes, it will be available on YouTube link. Those who have not attended, they can get it. That is not a problem. So I think we have completed all the questions. Okay. Yes.
I think I need some assurance from the Association of Structural A-Struct-P, that you will take a lead to bring the other bodies together and try to find a acceptable roadmap on this topic.
Yeah, I think now I will request Alok to sum up it and propose a vote of thanks and also address Mr. Kulkarni's concern.
Thank you, Manoj, and thanks Kulkarni Saab for such an excellent presentation. I mean, I was of course expecting this kind of presentation, but I see, considering very thin attendance, it is only a reflection of the kind of interest that this type of topics generate, and this is in fact a reflection of our society, particularly in our fraternity.
Yeah.
And this needs to be improved. So I have few takeaways from your presentation. First, you said very rightly that it is now time. This climate crisis has given an opportunity to structural engineers to join hands and to take a role of leadership.
Yeah,
This
correct.
is an opportunity in crisis for the structural engineers, and we must grab this opportunity with both hands. The good thing is that there is a global pressure for all the countries to sort of do something, and that is actually will be helping us,
Yeah,
because the political the governments, the politicians have no option but to do something. As you mentioned, the Paris Agreement has given some targets. We have to achieve targets or we are answerable globally. It's not just to answer your vote banks, but you have to answer globally also. So this is an opportunity. uh, what I listened to one very famous IABSE, past president, recently, about couple of months ago, and what he said is beautiful. He said that the politicians, the owners, the government, they have the power to take the decision, but no solution. The civil and structural engineers have the solution, but no power. And what is required is a bridge which needs to gap these two. You have to work. And as I said, this is a leadership opportunity for structural engineers. And instead of having too many associations working in a different direction, this is time to join hands, not only with the structural engineering association, but also with other
yeah,
like-minded
correct.
associations
Absolutely.
like Consulting Engineers Association of India. And your point is well taken. As president of IAS Structi, I can tell you that I have taken note, and we will move it forward and sort of do something about it.
Okay. Yeah, yeah.
Other things which I wanted to mention is, I was just going through one very interesting article by President of Institution of Structural Engineers UK, Don McQuillan. And that present, I wish we could sort of print it in ACD. That was a very good presentation where he mentioned the global scenario on climate change, and particularly in the infrastructure sector. And what he said is that though the significant cuts in the operational energy has been achieved over the years, in last 50 years, from 1980 onwards, there has been a lot of work, and there has been, I mean, it is net zero is a reality by 2030 or 2040 as far as the operational energy is concerned. But there is very little work done on the embodied energy,
Yeah.
and all the infrastructure works that we are doing, they are all embodied energy heavy. For example, in infrastructure bridges, there is operational energy is minimal. It is mainly the embodied energy. So there is a huge scope to reduce this embodied energy, and I think, as you said very rightly, that is the area where we need to work. Uh, and if there are no codes, no problem. Mr. Kulkarni is right. Let us try to give some kind of a guideline. Take cue from Institute Structural Engineers UK's, factors which they have given,
Yeah.
the carbon footprint factors. We have a association MOU with iStructi UK, by the way, and therefore we can, in fact, sort of work from there. We can start the work and move forward. Let's do something, and I'm sure the government will always support on these moves. Today we are deciding on the construction by L1, lowest cost.
Yeah.
Instead, it should be the lowest carbon footprint as the
Yeah,
criteria for
absolutely.
decision making, and we should
Absolutely.
move in that direction.
Yeah.
So with that, I profusely thank you, Kulkarni Saab, for initiating this kind of a webinar. This is the topic of the day, in my view, and we will have to also work to make sure that in future similar presentations we have more audience, and that also needs a lot of work, I can tell you. And I thank our moderator Manoj. You have conducted very effectively. And thanks to our other panelists, Mr. Sharma and Mr. Hegde, for your great insights. Thanks to all the participants also, though few, but at least the interactions have been good. Thank you from my side. Manoj, it's
Yeah.
all yours now.
Yeah, thank you, Mr. Kulkarni. And
Thank you.
once again, I thank all the participants, those who were present, and it was a really very lively, it was very thoughtful and very important discussion today we had. And I agree with Alok that we should have more such discussions, more such lectures on this topic, and we should make structural engineers make aware about the importance of this kind of aspect, and this must become our practice actually in all our designs, whether it is a mandatory or not mandatory, needed or not needed, but we should definitely consider the sustainability aspect in our designs. If our client is not knowledgeable enough, we should make them knowledgeable, and we should educate them, and we should incorporate these concepts in our designs if we are really doing some good job actually. So I think Alok, we need to do a lot of work in this aspect, in this
Yeah,
area.
lot of food for
Yes.
thought, and lot of work to be done.
Yeah. For
Times to
future,
come.
we got the new direction for the future, and I'm sure we will work on it.
And we will also include Mr. Kulkarni,
Yes.
for all this work.
Yeah,
Part of our
I'm
team.
willing. I'm a climate warrior, so
Yeah.
I'm always ready.
Thank
Rather,
you.
Alok, I would suggest that one of the issue of SED should be focused on sustainability aspects only.
I think we decided that the next
We decided
issue
that we need to convey
we have
to
already decided, and Mr. Kulkarni,
maybe the
we
guest
invite
editor.
you to be the guest editor for that
Okay.
journal.
That particular issue.
That issue will
I
be.
agree. I'm always ready to do this kind of job.
We will
Thank
send
you.
you an email. We will send you a formal email regarding this.
Thank you. Thank you.
Thank you. Thank you.
Thank you. Thank you all. Thank you for listening, and thank you for cooperation. And I extend, my gratitude to IA Shakti and all the participants. Thank you very much.
Thank you, sir. Thank you.
Thank you.